Alright, so we're going to talk about the graphs of sine and cosine and tangent. We're going to sort of look at these like you start off with any function. We're going to plot points. The general equation, you can have numbers in front. You can have a number in front of the x part. You can have a number that shifts it left and right, and you can have a number that shifts it up and down. Today we're going to focus on primarily the a and the b of it. Period. Sine and cosine are cyclical functions, meaning they repeat themselves after a period of time. Period is how long until it repeats. And so typically this will be a period of time, but it can also be just a distance. And amplitude is how high or low it goes. This is going to be a distance from equilibrium. Which is a fancy word for the middle. And I use equilibrium because it's more like physics. And then from the middle, because it's a distance, it's going to always be positive. So, graph of the sine function. So if you take the sine of x, you're taking the sine of angles. And so if your angle is 0, sine of 0 is the y at 0 degrees. So like that. So it's 0. Sine of pi over 4, that's the root 2 over 2. So the y value is root 2 over 2. That's the 0.7 approximately. And so we're going to plot these points. Sine at 90 is 1. Sine at 3 pi over 4 is root 2 over 2, or 0.7. Sine at pi, straight across, is back to 0 again. So we've gone up to 1, back to 0. And then 5 pi over 4 is down here. So that's negative 0.7 because we've gone down for the y value. And 3 pi over 2 goes straight down, and so you get negative 1. Back to negative 0.7, and back to 0 again. So, if we sort of plot this out, we're going to make it go until 2 pi here. And then half of that is going to be pi. Notice that after 0, it would continue in the same pattern if we kept going by the pi over 4, 0.7, 1, 0.7. And let's make this 1, make this negative 1. So when x is 0, y is 0. Pi over 2, we get to its highest point. And halfway in between there, pi over 4, we're at 0.7. Halfway in between there and there, we're at 0.7 again. Pi, we're at 0. All I'm doing is plotting the points that we just got. Negative 0.7, negative 0.7. The big thing to realize is that if we continue the pattern this way, same thing will continue to happen. If we continue the pattern this way, same thing will continue to happen. It's going to always be between 0 and 1. So what's the maximum of the function? 1. Happens at pi over 2, comma 1. And then every 2 pi. So you could say pi over 2 plus some 2 pi where n is an integer. So this is important because the maximums continue to happen. Happen at pi over 2 the first time, and then after another 2 pi, after another 2 pi, repeatedly, repeatedly, repeatedly. The minimum of the function is negative 1. Happens at pi over 2. Sorry, 3 pi over 2. Comma, negative 1. and then 3 pi over 2 plus 2 pi n. The period. It took 2 pi for the function to continue to repeat itself. This period will be the period of every sine function unless we change it. And what's going to change it is the thing that multiplies out front here, this b, and we'll talk about that. What's the amplitude of the function? I define that as the distance from the equilibrium. So how far did we get from the middle? We got one up and one down, and so the amplitude is 1. Again, it's a distance, always positive. And that's the sine curve.